In this video, we will be integrating some calculus problems using the Pythagorean trig identities. We use these in order to replace one of the trig functions with the other one, so that we will get an integral that is written in terms of one of the trig functions that we could easily integrate. Now let's do some examples. In this problem, we're integrating sine cubed of 3/5 x times cosine to the 6th power of 3/5 x. Now what we need to do is to rewrite this equation in terms of either sine or cosine. And to do that, we're going to use our first trig identity, which is sine squared theta plus cosine squared theta equals 1. In this case, let's replace sine squared theta and write it in terms of cosines. So what we will do is we will pull out the sine squared of 3/5 x and multiply this by cosine to the 6th power of 3/5 x. Then multiply this by sine of 3/5 x dx. Now we're going to use our trig identity and we're going to replace our sine squared. So we will get that to be 1 minus cosine squared of 3/5 x times cosine to the 6th of 3/5 x times sine of 3/5 x. Now we're going to use our u du. Now we're going to use our u substitution. So we're going to have u to be, our u is going to be cosine of 3/5 x. Therefore, du will be negative 3/5 sine of 3/5 x. So now let's rewrite this. Now let's solve for sine of 3/5 x. So this will be negative 5/3 du equals to sine of 3/5 x dx. Now let's replace everything. So we'll have an integral of 1 minus u squared times u to the 6th power times negative 5/3 du. Now this we could integrate easily, and we will get, after distributing this, we will get u to the 6th minus u to the 8th. So let's first pull out the constant in front, and then let's integrate u to the 6th. That will give us u to the 7th over 7 minus, now u squared times u to the 6th, that's u to the 8th. And the integral of that is u to the 9th power over 9. Now we will just replace u back with cosine to the 3/5 x. And that would give us 1/7 times cosine to the 7th power of 3/5 x minus 1/9 times cosine to the 9th power of 3/5 x plus c. That's it. Let's move on to the next problem. In this problem, we're integrating secant to the 8th power of 5/6 x times tangent to the 6th power of 5/6 x. Since we're integrating a function that has both secant and tangent, we're going to want to use the second trig identity, which is 1 plus tangent squared theta equals to secant squared theta. Next, we decide what we want to write this function in terms of. Is it going to be secant or tangent? So if we want to write this function in terms of secant, then we would have to substitute tangent. So u will have to be tangent of 5/6 x. In that case, du would be 5/6 secant squared x dx. And this looks like something useful because we could pull out a secant squared out of the equation and have that to be du. Now, what if we try to write everything in terms of secant? So then we will have to have u to be secant of 5, 6x. Then our du would be 5, 6 secant of 5, 6x times tangent of 5, 6x. Now, this could also be useful, but notice if we pull this out, we will have secant of 7th, secant to the 7th power of 5, 6x times tangent to the 5th power of 5, 6x, and then we would have the du here. But now we realize that we have odd powers. So in this case, if we write tangent in terms of secant, now we need to first find tangent squared of 5, 6x. And this would be to the what power? To the 5 over 2 power. Now, this is a power that you don't want to work with. Therefore, this is not something useful to do. So we're going to continue having u as tangent of 5, 6x. Now, let's first solve for secant squared x dx. So we're going to get 6 over 5 du to be secant squared x dx. Now we're gonna go and replace everything. So first thing to do is to pull out the secant squared x dx. So if we write this here, oh, by the way, this should be 5, 6 of x. So we're gonna have 5, 6x here, here, and here. Okay, so after we pull this out, so what we're left with now inside the integral would be secant to the 6th power of 5, 6x, tangent to the 6th of 5, 6x. Now what we do is rewrite this equation using our trig identity. First, let's rewrite that function on the side. So secant to the 6th power of 5, 6x. This could be rewritten as secant squared of 5, 6x to the 3rd power. And this is going to give us the 6th power. Now from here, we're going to use the trig identity and replace secant squared of 5, 6x. So we're going to get 1 plus tangent squared of 5, 6x, all to the cubed power. Now let's write this inside our equation. So we'll get 1 plus tangent squared of 5, 6x to the 3rd power times tangent 6th power of 5, 6x times secant squared of 5, 6x dx. Now we're going to use our u substitution. So we're going to have 1 plus u squared to the 3rd power times u times now secant squared of 5, 6x dx. That will equal to 6/5 du. So let's write the constant at front, 6/5, and we'll write the du here. And from here, this would look like something we could easily integrate. So first we distribute all of this. After distributing the function, we will get 6/5 times u plus u to the 7th plus 3u cubed plus 3u to the 5th. Now after we integrate, we will get u squared over 2 plus u to the 8th over 8th plus 3/4 u to the 4th plus 3/6 u to the 6th. And the last step will be to replace everything back with tangent of 5, 6x. After substituting tangent back into the equation, this would be the answer we will get. Here we are integrating cosecant to the 8th power of 6x times cosine to the 6th power of 6x dx. In this problem, it looks like we will be using the third trig identity, which is 1 plus cotangent squared theta equals to cosecant squared theta. In order to use this identity, we'll have to write this function in terms of cosecant and cotangent. To do that, let's remember which trig functions we use to represent cotangent. So cotangent would equal to cosine over sine. Of x. Since we don't have sine, we should note that, well, we could get that sine from the other trig function, which is cosecant, if we know that cosecant is equal to 1 over sine of x. So let's manipulate the equation a little bit. So what we could do is we could pull out a sine of 6x out of this equation so that we could turn this into cotangent. So what we'll do is we're going to pull out the cosecant of 6 to the 6x, multiply that by cosine of 6x, and then we're left with cosecant squared of 6x. And we know that this equals to 1 over sine of 6x. So what happens is cosine to the 6th power divided by sine to the 6th power. That will give us cotangent to the 6th power of 6x. And then we're going to have the cosecant squared 6x up front. Now we're going to use u substitution. So we're going to have u to be equal to cotangent of 6x. du equals to negative 6 times cosecant squared of 6x dx. Now it looks like we already have a replacement for cosecant squared of 6x. We could replace that with du now. And we can replace all the cotangents with u. So in this case, we don't need to use the trig identity anymore. So we could replace everything now. First, let's rewrite our du. This will be negative 1/6 du. This would equal to cosecant squared of 6x dx. Therefore, we're going to have this to be written as negative 1/6, and let's write the du at the very end. And cotangent to the 6th power is going to equal to u to the 6th power. Now this we could integrate. We will get negative 1/6 u to the 7th over 7. Now the last step would be to replace the u back with cotangent. So we're going to have cotangent to the 7th power of 6x over 7 plus c. There you go. Well, I hope this was helpful. See you in my next video.